What's up guys, welcome back to another LeetCode video walkthrough. Today we're going to be going over LeetCode number 46, permutations. Given an array norms of distinct integers, return all the possible permutations. You can return the answer in any order. And some examples are as follows. So if you have this array 1, 2, 3, the output would be all the permutations of 1, 2, 3, which means sort of all of the different orderings of these three numbers. And just by combinatorics, we know that the total number of permutations is 6 because there are 3 possible choices for the first element, 2 possible choices for the second element, and then only 1 choice for the third element. So you just multiply these three values together, 3 times 2 times 1, and you get 6. So a programmatic way to approach this would be as follows. A recursive backtracking algorithm would be best for this, where at each step, what we do is we exclude the first element in the list. So let's say we have the list 1, 2, 3, we exclude 1 and simply compute all the permutations of all the other elements. So compute everything other than 1. So 2, 3 is one permutation, and then 3, 2 is another. And then just add the first element to the end of each permutation, right? So we have 2, 3, 1 and 3, 2, 1. And then add these final permutations to a result array. And now after this is done, what we can do is we can move the first element to the end of the original list and repeat the same process. And the reason that simply appending to the end as opposed to in between each permutation works is because this in between step will happen naturally as the element becomes a part of the permutation input in subsequent steps, right? When we move it to the end, we're going to be computing all the permutations of the list with this element already included, so it's going to be everywhere. And we can guarantee a new permutation each time because the current element has technically never been the last in any permutation up until when it's deliberately appended to the end. So with that being said, we can take a look at a walkthrough of this test case. So we have 1, 2, 3, and yeah, let's just run through the call stack. So the first subsequent call that's going to be made is going to be 2, 3, and from here the subsequent call is going to be 3. Notice how each time we're excluding the first element, and this 3, because it's length 1, it's going to be returned back up to this current level. And what we do is we simply append 2, which is the first element, to the end of it, right? And now what we do is we move 2 to the back. So 2, 3 becomes 3, 2, and we run the same process. So the first element is 3, we leave that to the side and then compute all the permutations of 2. And because this is a single element, of course, the only permutation is going to be 2, and we add the element that we left out, which is 3, to the end of this. So 3, 2, and 2, 3 are the only permutations of 3, 2, and we return both of these to the top level. And at the end of each of these, we add the element that we excluded, which is 1. And we move 1 to the back. So 1, 2, 3 becomes 2, 3, 1. And we repeat the process. So this time we start out with 3, 1. Now we get to 1. And we add 3. Move 3 to the back. So this becomes 1, 3. Call it on 3. 3 is of length 1, so we return it back up. And we get our second and final permutation of this input array. And now we move both of these results back up to the very top and simply append 2 to the end of each of these. And now we move 2 to the back. So it's 3, 1, 2, and we run the same algorithm, exclude 3, run it on 1, 2, exclude 1, run it on 2, 2 is left length 1, return it back up, and add 1 to the end. So, move 1 to the back, so 2 automatically becomes the element we exclude next. And in similar fashion, we get these two arrays, and these float all the way back up. And this is what backtracking means, right? We make we go like deeper and deeper in a recursive calls, and then we backtrack the result up, and then we do something with the result. So each time we backtrack the result up, what we're doing is we're adding the element that we excluded to each of these results. And yep, these are the 6 arrays that we were originally seeking, and we were able to get them using this recursive backtracking algorithm. So that was pretty neat, and thanks for watching.